Hello, welcome to this new video on a complete roadmap for coding ground. And this video will be slightly longer because I am going to describe a lots of concepts in beginner perspective, and also I'm going to cover some advanced topics as well. So let's get into this video. This video starts with an alert as usual. If you're preparing for a specific company, you just prepare the particular coding topics usually asked in those companies. You can search in Prep Insta, Glassdoor, and there are so many sites for that. You can also use our How to Crack series because it's much company specific, covering interview experiences as well as the topics asked in the company. I will add the link in the description. And starting with the contents, because it's a longer video, I'm giving the contents in before starting the video as well. So the video starts with the program language to use, and we will cover when to start DSA, when to stop, and where to learn as well. So it's a complete full-fledged video. I hope this will be a this will help you a lot in your coding on preparation. So starting with the programming language to choose, I should not prefer this slide to be in this video, but in placement perspective, definitely there are some languages that are preferred a lot. So first preferred language is Java, followed by C++. So I have I've seen the job description of several companies. They are looking for Java and C developer in a fresher perspective, right? In a fresher point of view, they are expecting Java and C++. Then these three languages. But if you have mastered Python, if you have mastered C, you can go to the interviewer that I only know Python, I only know C, and you can write code in that as well. But most of the companies will allow these four languages, but there are some companies that are restricted only with Java and C++. So if you are going to start your journey on coding, you stay with these two languages anyone. But C is not that much preferable because it doesn't have oops. So if you have a given a system design question and you need to apply oops concept, C will fail in that scenario. So stay with the first three languages I have mentioned. Got it? We will be discussing about why DSA. So if you are a beginner, definitely this question arises. Even I too got this question. So the simple answer is anyone can give a solution for a problem, but the most preferred in IT companies are optimal solution. So in order to give an optimal solution, you need to understand some algorithms and data structures. So that's the reason we have the concept known as data structures and algorithms. Data structure is nothing but how the data is stored. So let me explain that. So data is the user data. User data can be of different types: integer, char, and boolean. That's why we commonly call these as data types. So to store these data types in a structured manner, we use data structures. Simple, right? So we use array, hash, of links, and there are several data structures to store these data types. And then followed by algorithms. So I mentioned that optimal solution necessary. To give an optimal solution, we need algorithms. So the next question is when to start DSA. If we can spend about 30 minutes, then you can start your DSA journey now as well. So you just need to have the knowledge of these 5 points, starting from variable and array declaration. So you just need to learn how to declare a variable and declare an array, declare a 2D array. If you know that, first point is done. And then you just need to know how to get input from user. You need to know how to print output in the console, and then followed by looping. And there's another loop as well, do while loop, but most preferably for and while is more than enough for a beginner perspective. And then the condition statement if else is more than enough. There's another condition statement known as switch, but I think if else is far enough for a beginner perspective. And learn a sorting method, preferably bubble sort. So I never included search because in for loop itself usually will use linear search, but that's enough for a beginner. So starting with regression and backtracking. The reason why I start with regression backtracking is, so after learning this 30 minutes of coding, definitely you will try to solve about 20 to 30 problems as well. So after solving that much problem, you will get an idea what is coding, how to solve a problem. Now you can jump to regression, and regression is the part where most of the developers will quit coding because the logic is hard to understand. The code will be so simple, but the logic behind the code is a bit larger. And let me tell you how to avoid these frustrations. First, memorize the logic. Don't hesitate to mark up the logic as a beginner. There is nothing wrong in that. Definitely, the code is going to be so small. Just mark up that at the first time. Got it. Then draw the flow of regression. This is very important. Let me show you a diagram. So this is an regression diagram for Fibonacci series. Draw the flow of regression. With the diagram you can understand the flow. Got it. So these three parts are most important. And when to use recursion. Recursion can be used only in iterative process, that if a particular thing is happening again and again, you can use the recursion at that point, which is very similar to loops, while loop, right? So I have shown the diagram for Fibonacci series, but this is not good to use in recursion is not good to use in Fibonacci series, but you can use in merge sort, quicksort, which is a divide and conquer algorithms like binary search as well. I will explain that in algorithms. So I hope you can understand these 4 points. Then comes to backtracking. Backtracking nothing but you move to this function, you move to that function, and you found that no, this is not the right path. So I need to make a small change in this regression path. I need to move this path. Got it? Then you will keep on moving this, and you found a wrong here. Then you will move this manner. So in this way, when there is an error occurs, when there is a wrong comes, you need to backtrack and you need to take a new path. So this is known as backtracking. And while doing backtracking, when you are backtracking, you need to undo the changes you made in this path, because this is error. So you need to undo the changes you did in this path, and you can take a new path. So got it? This is what we mention as backtracking. So this complete video will be only in theory perspective. I just need to give what is what. And then comes to data structures. So whatever I mentioned in dark green are so much important for product companies, and what I mentioned in green color, light green, are these are also important, equally important, but these are the mostly asked. And what I mentioned in here without no color are something that are not that much preferred as college placement perspective, but if you are planning for a Mang or a high package companies, definitely you just consider these as well. So starting with arrays and array list, you just need to learn all the methods that are used in these data structures. You just need to know what data structure needs to be used in what scenario. When it comes to parenthesis redundant check, you can go with stacks. And if you are working on some sums where you need to print a number of occurrences of a similar characters, you can use a hash map for optimal code. Got it? So optimal solution not only depends on algorithms, that also depends upon the data sources what you use. Before getting into algorithms, we need to discuss about time complexity. So as I mentioned, optimal solution, how we will describe a solution is optimal or not, because by using the time complexity, we usually describe as big O of n notations. I will explain that in here, this part. Okay. So first, time complexity doesn't mean that time taken to run a program. No, it's wrong. So I can give you an example as well. So you have two laptops, two desktops, which is a very old one, which is another is very fast. Comparing 1 billion data, old one takes about 100 years, and the new one takes about only 10 years. But here we are using an optimal approach, which is known as binary search. Using that, you have reduced that to just 10 years. Okay, but the new one you are using linear search, so there is no optimization, so it will take 10 years as well. Both has the equal time, but doesn't mean that both are using an optimal solution. Definitely not. Only the old one is using an optimal solution, because we are utilizing specs in a much better manner. That's why I mentioned here. Time complex describes how you utilize a spec given for you via number of comparisons. Got it? So when it comes to searching, for it's an example, for 1 billion data, if you start linear search, you will need to compare about 1 million comparisons. It will take up to 1 billion comparisons. While as in binary search, just 9 comparisons, because log of n can find it. Log of 1 billion is just 9. So when discussing time complexity, 2 power n, which is exponential, we should avoid that. Doing sub problems, we usually use this in brute force, and while sorting, we usually go with n square using bubble sort. If you do an optimal sorting, we will go with n log n, and for storing an element in array, we will use n. And for using binary search, you can have searching in log n, and for adding an element in a list, you will just need a constant time complexity. These are some beautiful examples that you will use in real time. Now we are here with our algorithms to learn. So whatever I mentioned in this green boxes, that are most important that everyone should learn, particularly for planning for product company in a college placement. What I have mentioned in this dotted blue boxes, these are very necessary if you are preparing for a Mang or a high package companies, if you are working in trees and crafts. But all these green are very much necessary that everyone should learn. Starting from pointers, there are Pointers usually used in sorted arrays. Two pointer and fast and slow pointers are the two types of algorithms available in pointers. Then we will have sorting algorithms. I'm not going to explain any of the sorting algorithms. You need to explore that. But this cyclic sort is a beautiful question, and you can solve a sorting sum in O of n. But there are some specific requirements that the sum should be in the range of 0 to n or 1 to n. And then we will have quick sort, which is one of the most optimal sort is quick sort. But in some situation when the pivot element is not taken in a correct manner, can end up with worst time complexity. So we will having insertion sort and a cyclic sort. Insertion sort is a good sort. If the array is partially sorted, you can sort the array in O of n as well. But in most of those cases, usually you will end up with O of n square. So I think we have covered sorting, we have covered 2-point and fast finder, and then we will having searching. Searching, there are several different kinds of search, exponential search, jump search and all, but binary search is more than enough. So now we will be discussing about arrays, and starting with patterns. Patterns is the not algorithm. Patterns are the kind of sums that are mostly asked in a placement perspective. So I have a full course videos on patterns. I usually approach the patterns in a manner, a simple 4 rules. Using that you can solve any problems. I can add that video link in the card as well, in the description as well. So next we have a union and find algorithm. This algorithm used to find disjoint sets, usually in sums where neighbors, friends, gifts transferring. These kind of sums you will be using this approach of union and find algorithm. Then followed by BF and DFS. This BF and DFS is also used in graphs as well. This BFS and DFS are used in maze sums and backtracking as well. So then we will have a flood and fill algorithm. This flood and fill algorithm will be utilized in multi-dimensional arrays, or where you are requested to change the value of a particular number to another number. Okay, altering the value of adjacent elements. So search for these algorithms, you will find what I mean. And next you will having Boy-Morris majority vote algorithm. This algorithm is used to return the element which is presented more than the half times of the length of the array. What I mean is, if the length of the array is n, if there is an element presented more than n by 2 times in the array, we will have that as the majority element, and we will print that element as the result. And there is another some known as Dutch flag problem. You just search that as well, which is also an important problem. So when it comes to max problem, you are requested to learn the below topics for me: bit manipulation, XOR, OR, and operations, shifting, and left shift, right shift. You should know that. Then followed by Euclid's LCM and GCD algorithm to find LCM and GCD, and then C of Eratosthenes for finding the number of prime numbers within a given range in optimal manner, and to find log to base 10 to find the digit of a number. Right. So next followed by substring, substring or subarray, whatever. Substring or subarray. You have about 3 different kinds of algorithms. Starting with sliding window, I can explain sliding window in a representative manner. Then cadence algorithm. Cadence algorithm used to find a maximum or minimum number, minimum subarray within the given array. Like if you add up all the values in the subarray, you will get the minimum value, or if you add all the value in the subarray, you will get the maximum value. So, and then we have a KMP algorithm. KMP algorithm is used to find a pattern in the given string. If you can find a substring is available or not using the pattern. So I think you have covered these as well. Then we have a linked list. Linked list is a data structure, as I mentioned. So in the linked list, you need to learn about reverse the linked list. You need to learn about merge the linked list, and the Floyd cycle. This Floyd cycle is nothing but the force and slow pointer, but especially for detecting a cycle detection. And then we will have trees and grass. I'm not going to explain a lot in trees and grass. I can give you some insights that topological sort means sorting a graph. It's a method of sorting a graph, and DBS or TFS, as you know, it's a searching algorithm, path searching. And then followed by Dijkstra. Dijkstra is applied only in weighted graphs with non-negative numbers, and Belfort graph can be applied in weighted graphs with negative numbers as well. Then Floyd-Marshall algorithm. Floyd-Marshall algorithm is used to find the shortest path for the given vertex, nearest shortest path in the given vertex. and A star. In A star we will be using heuristics functions as well. So that's something I know in definition basis. And I hope I have covered a lot. And I just needed to learn only these green boxes if I'm preparing only for college placement. So I think I have covered some basics about phi algorithms only theoretically, but I hope you got some knowledge on that. And then we will be having dynamic programming. So I am having this in a separate slide. This is most important when you're preparing for man companies as well. So the dynamic programming consists of two concepts. One is overlapping of subproblems and another is optimal substructure. So what does it mean is overlapping subprobleming. Consider first you need to learn recursion because you are going to optimize the codes that are in recursion only. So what is memorization mean? I will explain right now. So take this example. In order to find the sixth element in Fibonacci series, you need to know the fifth and fourth element, right? By adding this two element, you will get the sixth element. In order to find fifth element, you need fourth element, third, two, one. Literally, same thing is repeated here as well. So this type of approach is going to overflow your stack. That's so you can see this much of memory is wasted. So what we can do is we can store these data subproblems data, and we can use that to solve large problems. So this type of approach of storing the data is known as memorization. And literally in dynamic programming, we can solve this problem just by using arrays where the data is keep on storing in the arrays, and by accessing the data we can solve this up. Then we will have a optimal substructure. What does optimal substructure mean is if you need to find a path to A to C, you need to find the optimal path from A to its nearer vertexes and C to nearer vertexes, and you need to find a common vertex to join these two. Right, next you can find all the possible path from A, which is A to D, A to B, let it be E, and A to E. Got it? So the most optimal path is A to B. And similarly, search in C, C to D, C to B, and C to E. The most optimal path is C to B. Then definitely A, B, C, A to B, and B to C is the optimal path to travel from A to C. So this is the way of approaching. So we will subdivide the sum. We will find we have subdivided the sum into two and find two optimal solutions, and finally we got the most optimal solution. And the algorithm what you are using here to find all the possible path of neighboring vertices is Floyd's Warsel algorithm, as I mentioned. This is the most important slide, that is when to stop. So if you are someone who is planning for a service company, there are some frequently asked questions. You can prepare that questions as well. That's more than enough. Instead of learning these much concepts, you can learn frequently asked questions, and also learn arrays and 2D array sums. That's more than enough for a service company. But when it comes to a product company, you must learn arrays and 2D arrays followed by recursion, hash maps. These are most important. And then some companies also ask you linked list and stacks and queues as well, and you need to master that as well. Got it? And these frequently asked questions are also necessary when you are sitting for an technical interview. The interviewer might ask you to solve a sum which is frequently asked in most cases, like swapping a number. Then you need to learn old man questions. In recent times of placement experiences, what I get from juniors and myself, I am seeing lots of questions that are asked in previous man questions, right? So companies are asking those questions in their coding round. Please prepare old man questions just for these topics as well. Got it? Then followed by heaps and trees. That's not that much prioritized, but if you're studying, that's truly good. Got it? And then man companies. If you are preparing for man, which is Microsoft, Google, Netflix, Amazon, if you are preparing for that big companies, whatever we learn in this roadmap are necessary. And because if you are preparing for a company to that level, then they will expect you to have a knowledge of this level, right? Now we will be discussing about where to learn and practice. So particularly DSA. So my first preference is take you forward, that is Triverse datasheet, because it's not language specific. Even though the starting sound starts with C++, but mostly after a mid and advanced questions will be solved in pseudocode only. We can use that. And then we will be having Kunal Kushwaga's DSA, complete DSA bootcamp, where he will be covering all the sums in Java. I just started my DSA journey with Kunal Kushwaga only. It's really amazing. But currently, if you are looking for a vast concept, you can just stay with, take you forward. And then if you are learning Python, I suggest NeetCode, because neetcode.io is a website where NeetCode admin have shared just 150 sums. Using that 150 sums, you can complete all the DSA concepts you need to learn. So you can use, but the complete video will be in Python. So then Akshay Shen is JavaScript. JavaScript, I haven't seen in my personal experience people using JavaScript in DSA, but there are people using, I know. But in my personal experience, no. Then C, that Jenny's lectures for C is there are about 200 plus videos I hope in the playlist, but she's covering in such good manner. So when it comes to practice platforms, my first preference goes to Lead Code, because I have seen people showcasing their coding skills in their resumes by saying how much problems they have solved in Lead Code. So I think people are recognizing that. Then we can also start with Lead Code as well, and followed by our own product, which is Code Club channel, which is a channel with about around we are closing towards 200 followers. We are posting questions. We are currently in our 180 plus days of coding. You can just join the channel. You can solve that sums as well. Then followed by Geek for Geeks, Code Chef, Hacker Rank, and Nakuri Code 360. Very recently, I gone through this website. It's pretty super. That it consists of most of the old man questions, and they don't give you a solution directly. So it's a healthy approach of approaching problem than Lead Code in my personal friend. Then do's and don'ts in the interview round. First, do's. So you need to be positive, have a simple smile. If there is an interviewer, clarify the doubts that you get in the question, and keep on interacting with the interviewer. Disclose what are the techniques that you are going to approach to solve the problem, and start with a simpler approach. Don't try to start with the optimized approach. Sometimes you time may exceed, and you don't get a time to solve the problem. You are planning to make it optimized, and you never solve a single test case. Then you are the one who is going to lose. Start with a simple approach, solve the problem, solve some test cases, then go to an optimal solution. Then at the end of the at the end of the coding, have a healthy conversation with the interviewer about the company, what role you are going to assign, and such kind of stuff. And then what are the don'ts? First thing, never dive into a sum. Just you are getting at the time of getting a sum. Don't dive to solve the sum. Analyze the sum, analyze the edge cases where the sum, the approach can get failed, and try to optimize that. Alright, then don't be defensive. If the interviewer is asking you to change a part, or if the interviewer is asking you to make a change in the code, don't be defensive or say that no, this is only right. No, let him say, you just change that, because the interviewer is usually be a team leader. What the team leader expects is the collaborative teammate, right? Yeah, and he need to be coordinate with him. So he don't need a guy who is defensive. So this is a simpler approach. So I think I've covered everything. Maybe this video can be much lengthy than my previous videos, because this video is more important, I personally prefer, because I love coding. So that's all this video, and thank you for watching the video. As I mentioned, so let me explain how each algorithm works, some of the algorithm works from my knowledge. So let me explain what is two-pointer approach. So here we have taken a problem where we are given an array of 5 elements. The target element is 7. What does it mean is, if you sum up 2 elements in this array, you need to get the target value 7. This is known as 2 sum. The problem name is 2 sum, which is so classic problem. Have taken 2 pointers, let it be I and j, whatever you call. Let me push this pointer to the next element, add these 2 elements, which is 3. No, we don't get the element. If the resultant element is lesser than 7, push this, right? Got it? So this is lesser than 7, push. This is now 1 plus 3 4, still less, push this element. 1 plus 4 5, still less, push this element. 1 plus 5 7, still push this element. Now you crosses the boundary, so stay back, move this to 1 point. Now we get 2 plus 5 7. Therefore these two are the sums that we are required. Now you will move this to here. Now we will get 3 plus 5, which is exceeds 7. we will move back this. Now we will get 3 plus 4, which is also 7. We are getting our second result as well. And then if we move 3 plus 7 is 7, we don't move this. Now if we move this here, definitely the breaking condition that when blue pointer exceeds red, this is the breaking condition. Here the sum will stop and return the results what we get. So I hope you understand how the two pointer will be useful. So the optimal part is you just need a only one loop, because in both loops this will be, you need some if condition, and a single loop is enough instead of multiple loops. So let me explain how the binary search works. For given an array of 5 elements, the target element is 2. The question is to find the index of this element. Got it. So in linear search you will linearly search 1 2. Oh, here is 2. That's it, I got the answer. So but in binary search, not this way. So in binary search, how it works is you need to take the mid of the element. How we will find the mid? So low plus high divided by 2 is mid. So 0 plus 4 divided by 2, which is equal to 2. So 2 is the mid, so this is the mid. So first you will search whether the mid is equal to the target element, and then you will compare whether it is lesser or greater to the target element. Comparing mid. Okay, first you will check whether the mid is equal to target element. No, that's not right. So this condition fails. And whether the 2 is greater than 3, definitely not. If 2 is not greater than 3, and this is the sorted array, it should be sorted array, then definitely there is no reason of searching in the right side, right? So just cut that out. So then we will search in the left hand side. So we will take this part, and once again we will assign low to high. So here low is 0 and the high is 2. 0 plus 2 by 2, which is 1. So we will take now the mid is 1. So now we will compare where 2 is equal to 2. Yes, 2 is equal to 2, we got the target. So the return the index as 1. This is the result. Got it. So this approach is known as divide and conquer, what I mentioned in recursion, because we are dividing and we are approaching. So starting with sliding window. Sliding window is nothing but if you are given a sum of they are mentioned a window size as 2. They are mentioning window size, definitely it's going to be, mostly it's going to be a sliding window problem only. They mentioned that window size is 2, and you need to find the subarray of size 2 which has the maximum subarray. So let it be unsorted array 8 and 10. So you will take a window size of 2, and starting with the first element you will add these two elements. 10, you will get 10. Then we will move to these two elements, we will get 12 which is greater than 10. Now the maximum element 12. Then we'll move the sliding to the next level, next, and 10 plus 4, which is 14. 14 is greater than 12, so 14 is the current biggest number. So then we will move to 10 to this, then which is 9. 9 is not that much greater than 14. So at this subarray we got 14. 14 is the maximum value. 14 is the subarray with the maximum some value. Got it. So what you have did, every time we push the subarray, we will remove the first element, add the next element to the first element, and the last element will be a new element, adding a new element to the last element. This process repeatedly takes place in a sliding window. Got it. When the sliding window ends, if we get an index out of bound at a point, so we will stop the sliding window at that point as well. So the overall time complexity is O of n. So if you don't try this approach, you will end up with the O of n cube as well, cubic time complexity as well. So I hope you can understand why you need sliding window. Then I will explain fast and slow pointer using Floyd cycle. So now let me explain you what is fast and slow pointer using Floyd cycle detection algorithm. So I am going to explain you two algorithms: Floyd cycle detection algorithm and fast and slow pointer. Let this green be fast pointer and this blue be slow pointer. The problem here is to find this cycle, whether a cycle is present or a cycle detection. And when these two pointers pointing to the same node occurs at this point, then we can say that yes, there is a cycle present. Let me show you how. This fast pointer moves two nodes for every iteration. This slow pointer moves only one node at every iteration. So this will point to this at the first iteration. Next iteration, this will point to this. Oh, you can think both are pointing to the same node. Then we can say there's a cycle detection occurs. No, No, not like that. The iteration ends at the slope pointer. So the slope pointer needs to move one point apart, and then the fast pointer moves two nodes, and once again the slope pointer moves one point. At a point you can find these two pointers pointing to the same node, then definitely we can conclude that there's a cycle detected. But this is known as Floyd's algorithm, cycle detection algorithm, and we can move this. So the final algorithm what I'm going to explain you today is the reversing a linked list. So you need to point the head to null because the head is going to be tail, right? Tail point to null, and your head is initially pointed to this node, so you can access this node using your head. So you can access this node and make this node to point head. Got it? Not this. Similarly, this node can access this, make this node to access this node in the reverse order. So similarly, you can make this as well. And at a point when you came to know here there's a null, right? You know there's a null. This is the tail initial tail. If at the point when you know you have reached that tail by finding the tail dot next is equal to null, you can literally swap this title. Like this is the head. Make this node as head. This is how the this is how we will be reversing a linked list.